Copyright 2014, Math Diagnostics and Intervention, all rights reserved. We're going to learn about similar triangles. And a problem for similar triangles might look like the one you're seeing right now. There are several questions that you could be asked about similar triangles, and the first question you might be asked is, are these two triangles in fact similar? The answer to that question in this case is yes, they are. The way you can tell these two triangles are similar is that you have angle A with one tick mark, showing that it is congruent to the one tick mark angle, angle Y. So angle A is congruent to angle Y. You also have the two tick marks in angle B congruent to the two tick marks in angle Z. Therefore, angle B is congruent to angle Z. We have two angles in one triangle congruent to two angles in another triangle. Therefore, by angle, these two triangles are in fact similar. The next question you could be asked is to write the similarity statement for these two triangles. One way that question could be asked is, you have triangle CAB is similar to, the wiggly symbol there is the math symbol for similarity, triangle blank. And the trick is we have to find the corresponding angles in our second triangle and write them in the proper order. Angle C in the small triangle is listed first, and it has no congruency marks attached to it. Therefore, angle C will correspond to the angle that also has no congruency marks in it in the other triangle, angle X. And since C is listed first, angle X must be listed first in our similarity statement. Angle A is listed second. It has one congruency mark in it, and angle Y also has one congruency mark. And since angle A is congruent to angle Y and angle Y is listed second, angle A is listed second, angle Y must also be listed second. And finally, we have angle B with two congruency marks and angle Z with two congruency marks, and they would have to be listed last. Since angle B is listed last, angle Z will also have to be listed last. Therefore, we have triangle CAB is similar to triangle XYZ. Another question we could be asked about similar triangles is to find the scale factor. To find the scale factor, I need to find two corresponding sides in my similar triangles that have numbers attached to them. Let's take a look at the side that is 12 in our larger triangle and find out what side it corresponds to in our smaller triangle. The side length of 12 is between our one congruency tick mark for Y and our two congruency tick mark for Z. The one congruency tick mark is A and the two congruency tick mark is B. So that leaves X as our corresponding side length. And since X is not a number, I can't use the corresponding sides of 12 and X to find my scale factor. So I'm going to keep looking, and I'm going to look at 4 and 6. 4 is between the two tick mark congruency of angle B and the no tick mark of angle C, and my 6 is between the two congruency tick mark for angle Z and the no congruency mark for X. Therefore, those two angles are two sides are corresponding. My sides of 4 and 6 correspond to each other because angle B is congruent to angle Z and angle C is congruent to angle X. Therefore, the side between those two corresponding angles will be the corresponding side. And since both of those have numbers attached, I can use them as my scale factor. I can write this scale factor in at least 4 different ways. I can write it as the small triangle to the large triangle, 4 to 6. I could write 4 to 6 in the lowest terms of 2 to 3. However, there's no reason why I couldn't go from the large triangle to the small triangle. My scale factor could also be written as 6 over 4, or in lowest terms as 3 over 2. Any of those four scale factors will be correct, and any of those four scale factors will also be usable in finding the missing side lengths that we're about to find next. I'm going to use the scale factor of 2 to 3 to help me find my missing side length of x. 2 to 3 went small triangle to large triangle, and as we saw before, x in the small triangle corresponds to 12 in the large triangle. I can cross multiply this because I have one fraction equal to another fraction. That gives me 2 times 12, which is 24, equal to 3x. Divide both sides by 3, and I get that 8 is equal to x. I now need to find my measurement for side length of y. Y is between my one congruency mark for y here and my no congruency mark here for x. That will correspond, my side length of y will correspond to my one congruency tick mark for A and my no congruency tick mark for C of 6. Therefore, I can use 2 over 3, small triangle to large triangle, corresponds to small triangle of 6 to large triangle of y. Cross multiply, we get 2y is equal to 18. Divide both sides by 2, and we get y is equal to 9. That covers the types of questions you might be asked for similar triangles, and as long as you manage your details properly, you should have very little difficulty in solving your similar triangles problems.